Welcome, everyone. Good evening. I'm Janelle Gurley, and I'm the Director of Science and Programs here at the Maria Mitchell Association. And it is my distinguished pleasure to welcome Dr. Regina Jorgenson this evening for her presentation, The Great North American Eclipse of 2024. As we are embarking on a really historical moment for us here in North America with the upcoming solar eclipse, where we'll have 87% partiality or partial coverage here from Nantucket rather. It's really exciting to have Dr. Jorgenson with us this evening for our Science Speaker series to share her musings and her findings and her everything about eclipses. Sorry, I'm so excited that I'm getting a little tongue twisted. Before we begin, I'd like to share a little bit more about what Dr. Jorgenson will be presenting this evening and her background as well. And then I will turn things over to Regina. So for the Great North American Eclipse of 2024, on April 8th, 2024, a total solar eclipse will cross a large part of the North American continent. This will be the last total solar eclipse across North America for the next 2 decades, making this a do not miss event. Millions of sky watchers from across the country are expected to travel to the path of totality, an approximately 115-mile wide swath that stretches from the western coast of Mexico up through Texas, the Midwestern states, and through parts of New York, Vermont, New Hampshire, Maine, and eastern Canada. In tonight's talk, Dr. Jorgenson will share a brief history of eclipses, focusing on the astronomer Maria Mitchell's experiences and legacy, and then discuss what to expect and how to best prepare for the upcoming April 8th solar eclipse, whether you will be here on Nantucket experiencing a partial eclipse, or if you are fortunate enough to be in the path of totality. The talk will be followed by a Q&A session, so if you have any burning questions or any musings that you'd like Dr. Jorgenson to address this evening, she will be available for that. And just some more background on Dr. Jorgenson. She's the Director of Astronomy here at the Maria Mitchell Association. And as an undergraduate student, Jorgenson's formative experience as an NSF-RU intern at the Maria Mitchell Association helped inspire her to make a career out of her love for astronomy. Dr. Jorgenson received a BS in physics from the University of Puget Sound and an MS, rather a MS, and PhD in physics from the University of California, San Diego. She held research positions at Cambridge University in the United Kingdom and at the Institute for Astronomy in Hawaii before becoming the director of the MMO in 2016. And it is my, again, distinguished pleasure to welcome Regina this evening. Welcome. How are you?
Hi, thank you so much. I'm doing well. Thank you for that introduction.
Of course. Well, I'm excited to learn all about what you have to share this evening, and I'm sure that everyone who's joined us is as well. The screen is yours when you are ready.
Okay. I will go ahead and get this going here. And do this. And this. So can you see my slides okay?
Yes, looks great.
Okay, great. All right. Hi, everyone. I'm very happy to be here and thank you all for coming. I'm a little bit sad we're not doing this in person. I kind of miss the days of the in-person Science Speaker Series, of course. However, it is great to know that I think there's folks out there listening from across the country. So that's a bonus of doing things on Zoom. So anyways, thank you for coming tonight. I am Regina Jorgenson. I'm the director here at the Maria Mitchell Association, director of astronomy, I should say. And I'm super excited because we have a really fantastic astronomical event coming up, as Janelle was already saying, which is the Great North American Eclipse of 2024. My background picture here that you're seeing, I'm going to come back to that in a future slide. So I'm going to go ahead and get started. As Janelle said, I'm very happy to take questions. So if you have questions, please go ahead and pop them in the Q&A or in the chat box, whichever one's available, and we'll take those all at the end. So just a little bit of background to get everybody on the same page. Of course, we're the Maria Mitchell Association, and Maria Mitchell actually had a really close connection with several different solar eclipses. And so I'm going to start out with a little bit of background about that. So in case you didn't know, Maria was born here on Nantucket on August 1st in 1818. And she was born in what we now call the birthplace house, which is the house on Vestal Street at 1 Vestal Street. And one of the first significant events in her life, especially relating to eclipses, was that on February 12th in 1831, when she was 12 and a half years old, she actually observed a total solar eclipse that took place on Nantucket. So in that case, Nantucket was actually in the path of totality. And she observed the eclipse from their house on Vestal Street with her father. And Mariah's job during the eclipse was to very carefully count and record the seconds of the eclipse. And using that information, sort of the eclipse timing, they were able to figure out and calculate the longitude of the house on Vestal Street. And this was a really big deal because it's very difficult actually to determine longitude. Latitude's much easier, you just need the North Star. But longitude is a little bit of a different ballgame. And so Mariah actually played a pretty important role in that that experiment, if you will. And it's kind of amazing too at age 12 to have the sort of tenacity and foresight to be able to do that, especially when you're experiencing a total solar eclipse, which is just an absolutely mind-blowing experience. So here's a picture of the birthplace house on at 1 Vestal Street. And you can see in the background on the left the observatory now, which was built after Mariah passed away in 1908. With the little silver dome. And then on the right, you're seeing a picture of the front sitting room, which is where they observed the eclipse from. And the telescope you see there is actually the little Doland telescope that Mariah discovered her comet with, which is a different Mariah story. But just for completion, are some other important noteworthy times in Mariah's life. Of course, on October 1st in 1847 is the famous story of Mariah when she discovered a telescopic comet, which is a comet that is not visible by eye, but you need a telescope to see it. And of course, she did this down at the from the roof of the Pacific National Bank on the top of Main Street. With that came a lot of fame because the King of Denmark was giving gold medals to people who discovered telescopic comets at the time, and Mariah ended up winning this gold medal. And the next year, in 1848, she was inducted into the American Academy of Arts and Sciences. And then the following year, she was actually hired by the US Nautical Almanac to track the position of the planet Venus. And this is really where I think we start to call her the first professional woman astronomer in the United States, because she was being paid to do her astronomical work. The next year, she became a member of the American Association for the Advancement of Science. And then in 1865, she was appointed professor of astronomy at the newly opened Vassar College. And in fact, she was the first person hired of any gender by Matthew Vassar when he decided to open his new college. In 1873, she became a founding member and later president of the Association for the Advancement of Women. And she passed away in 1889 and is buried here on Nantucket. Here's a picture, painting actually, of her father. And I think this was supposed to be Mariah. It was not Mariah because she hated to pose for photos. So it was one of her sisters, Eliza. And what's kind of interesting about this picture is the clothing that she's wearing. They were Quakers, and so they would not actually have worn such fancy adornments with the white collar, with the kind of looks like fur, probably. They were not normally going to be found in such kind of elaborate and fancy clothing. But back to eclipses and Mariah. So she experienced the first total solar eclipse when she was 12 right here on Nantucket. Her next eclipse happened in 1869 in Burlington, Iowa. She actually traveled with a group out to Burlington, Iowa. And you can see here in this photo, Mariah is seated in the front row. And she is actually, of that group, she's the second from the right. So there's a man with a hat, and then next to him is Mariah sitting there. So she experienced another solar eclipse that she actually traveled to, because of course the path of totality of a total solar eclipse tends to be quite small. And so if you want to see it, you have to make sure you're in the path. And then a little bit later, she did another eclipse trip to Denver, Colorado. This was to see a solar eclipse on July 29th, 1878. And in this case, one of her sisters is, you can see in this picture, Phoebe, and she actually came along to make sketches. And here you can see them sitting, and they've got their telescopes prepared to actually observe the eclipse. And here's a quote from Mariah about this event. Looking along this dark strip on the map, each astronomer selected his bit of darkness on which to locate the light of his science. My party chose Denver. So, they had to make pretty careful plans. And of course, traveling in those days, was a lot different than it is now. And you had to plan well in advance. And, I'm sure the journey was arduous. And in this case, Mariah had taken along several students who you can see in this picture from Vassar, who were women, of course. And it's quite interesting because at that time, women didn't typically travel, and certainly not alone. And so this was a group of women who caravanned all together to all the way across the country to Colorado to observe a total solar eclipse. This is an image that I wanted to show. This was on my title slide that somebody drew of that total solar eclipse, in fact. So this is a drawing, and the artist, his name is, you can see at the top of the slide, Etienne Trouvelet, excuse my pronunciation, who was a French artist, astronomer, and an amateur entomologist. And I was reading up a little bit about him because he seemed like an interesting character, and he was actually responsible for introducing the spongy moth to North America. And apparently that was an extremely invasive moth and did millions of dollars of damage to forests, and is still a problem today. So he maybe should have stuck to astronomy and not entomology. But in any case, I think he made a bit of a living doing astronomical drawings and representations like you can see here. So what you're looking at, of course, is the solar corona, so the extended outer atmosphere of the sun, which is extremely hot, millions of degrees, and we'll come back to that later. And then the black circle in the middle, of course, is where the disk of the sun is, but also now the disk of the moon is covering it, and that's why it's completely dark. So just a little bit more on Mariah. Of course, she was very famous. She has a crater on the moon named after her, and you can see it here pointed out by the arrow right next to the larger crater named after Aristotle. And in case you didn't know this interesting kind of fun fact, there are about 1,200 people with named craters on the moon, and of those, 20 are women. Of those, 7 are American. And of those, 5 are associated with the Mariah Mitchell Association. So Mariah and several of her former students and others who were associated with the MMA at various times. And I list their names there. I have just a couple interesting slides. When I first started in this position, I found this book in the astronomical study, which was my office. And you can see here it says Record Book of Astronomical Work. And I opened it up, and lo and behold, right there on the first page, I'm going to zoom in here, and the beautiful, beautiful writing. In 1905, there was a talk given on eclipses by, and it's a little harder to read the name, but it looks like Harriet Barrel of Boston. And so I saw this shortly after I started, and I was actually about to travel to the 2017 total solar eclipse, and I'll talk about that in a little while. So it was kind of fun to just make that connection with this history that's over a century old at the Mariah Mitchell Observatory. One other thing that I want to show here that I've discovered is, if you don't know, the observatory has a photographic glass plate collection that is very extensive, over 8,000 photographic glass plates of the night sky taken back until when the observatory was first built in 1908. And these are basically photographic emulsions, kind of like the old-time photography, except the substrate or the surface is glass instead of a film. And so the idea, though, is similar to that negative. So wherever you have dark, that's where photons of light have exposed the emulsion. And so think of this as a negative. So wherever you see dark, that's actually where the light is. And so what you're looking at on the left here is a photographic glass plate of a different total solar eclipse that happened on Nantucket in January 1925. And again, so in the center is the sun covered by the disk of the moon. And then you have this extended solar corona radiating outward. And it was captured really nicely here on this photographic glass plate. So kudos to the astronomers who were here at that time who actually managed to capture this for posterity on this great glass plate. Okay, so we're going to move forward now to the current eclipse and talk a little bit first about eclipses, what they are, why they happen, and then go into some details about this upcoming eclipse next Monday and what we can expect. So I'm going to start out with a little bit what I'll call Eclipses 101, and then we'll talk a little bit about how to safely enjoy them and observe them, especially during the partial phase. And even though it's not going to be partial here on Nantucket, I do want to talk a little bit about why is it such a big deal, and what's really special about a total solar eclipse. And then I have a couple extension topics that I'll talk about if we have time. Okay, so usually when I'm in a room with people, I like to ask them, have you actually seen an eclipse and what is going on? So here are two different types of eclipses that you might have seen on the left side, and that's different than on the right side. So if you've seen an eclipse, which one do you think you've seen? Or maybe you've been lucky enough to see both here. So the difference, of course, is that the image on the left is a lunar eclipse. That is actually a picture of the moon, and it's reddish colored because it's actually being eclipsed right now in this image. And the image on the right is a picture of the sun that's being eclipsed by the moon. So that dark arc that's coming in that kind of looks like it's taking a bite out of the surface of the sun is the moon. And so on the right is a solar eclipse. So generally, eclipses, both solar and lunar eclipses, happen when the sun and the moon and the earth line up in a very specific way, such that they cast shadows on each other. And we'll look at a cartoon representation of what we mean here. So here on the top, you can see the arrangement. Of course, nothing here is to scale, and this is a cartoon, so this is absolutely not physically accurate in terms of sizes or scales, but it's just to give you an idea of which body is where when these different things are happening. So in a solar eclipse, you can see that the moon passes in between the earth and the sun, and it casts a shadow on the earth. In a lunar eclipse, the earth passes between the sun and the moon, and it casts a shadow on the moon. So here's another great tweet by a wonderful astronomer, Katie Mack, who tweeted this out once, so you can remember the alignment of where things are during which type of eclipse. So you can see in a lunar eclipse on the top, you have the sun, you have the earth, and then you have the moon. In a solar eclipse, you have the sun, and then you have the earth. I'm sorry, the moon, and then the earth. And if it's the other way around, if you have the sun in between the earth and the moon, it's apocalypse. So that is nothing, of course. But so one way you can remember this is which one gets darker. If it's the moon, it's a lunar eclipse. And if it's the sun, it's a solar eclipse. So that helps you remember which is which. Maybe that will help you. Okay, let's look a little bit more in depth at the actual geometry of a solar eclipse, because we're going to focus now for the rest of the talk on solar eclipses and what they are. And so here, again, nothing is to scale in this image. This is merely a cartoon representation so that we can start to understand how the shadows are created and the different parts of the shadow. So in a solar eclipse, of course, we have the moon casting shadows on the surface of the earth. And what you can see here in this diagram is that there's sort of two different regions of shadow. There is the full shadow, which is indicated, you can see it says full shadow on the slide and has an arrow down right behind the moon. And that's sort of the deepest, darkest part of the shadow. And if you look at how that cone kind of extends, it makes a little black circle on the surface of the earth. And indeed, inside that black circle, people there would be experiencing a total solar eclipse because they're in the darkest part of the shadow. However, you can also see now these purple regions, and this is where the shadow is not as intense. It's not as dark. It's not as complete. And folks that are in that area are experiencing a partial eclipse. So this is where the surface of the sun appears to be partially blocked. That's what's going to happen here on Nantucket in this upcoming eclipse. So that's what here the jargony vocabulary words are umbra and penumbra. So umbra is the full shadow and penumbra is the partial shadow. But I think it's really best to actually look at images of this because it's very impressive. And fortunately, we live in a time when we have satellites, we have the International Space Station, we have cameras in space orbiting around the Earth that actually look down at the Earth and can take a picture of this. And I think this is the best way to really visualize it. So this is an image of the Earth taken from space in 2016 when there was an eclipse. And just in case you can't see it, I've drawn a red circle around it. So this is what we're talking about here. This dark area is actually that umbral shadow on the surface of the Earth. So the moon is casting that shadow onto the Earth, and everybody inside that dark circle is experiencing a total solar eclipse right now when this picture was taken. Hopefully this plays. Yeah, so this is the same thing, except now this is a GIF showing over time, both, of course, how the Earth is spinning, but also how the shadow is moving across the surface of the Earth. And so you can see that, the eclipses happen over a certain amount of time. It depends exactly on the alignment and whatnot, but it's usually typically a few hours as the shadow crosses over the Earth. And of course, the Earth is spinning underneath that. So that's what creates this sort of path of totality. And in fact, here is the path of totality for this upcoming April 8th eclipse. And so one of the reasons why this eclipse is exciting and there's going to be a lot of news and whatnot about it is because everyone in North America will be able to experience at least some type of partial eclipse. And that's what you can see. I mean, as long as you have clear skies, of course. If it's cloudy or overcast, that won't be possible. But if the skies are clear, everyone in North America will be able to see at least some type of partiality. And so what you can see here on the map is the yellow strip that kind of goes from the lower left to the upper right is the path of totality. So everywhere along that yellow strip is where folks will experience totality, experience a total solar eclipse. If you are outside of that path, you will only experience a partial solar eclipse. And if you look sort of carefully on the right and left edges and even the bottom here, it sort of has lines indicating how partial the eclipse will be, what percentage of the sun will be covered at those various locations. And so if you are located somewhere, there's lots of tools online that you can actually go online and check out how partial it'll be in your location and in the timing, exactly when things start and when things end. But what's really cool about this eclipse is that about 32 million people live along that path of totality. It happens to cross through several major cities. And an additional 150 million live within about 200 miles of the path of totality. And so it's predicted that millions of people will be actually experiencing this total solar eclipse. And this is one of the reasons why this is a really, really big deal, because the path happens to lie along a big portion of the population centers of the United States. Just to compare, some of you may remember we had another great North American total eclipse in 2017, and I wanted to just quickly point out some of the comparisons to that one. You can see the path here. It goes from the upper left, so Oregon area. The eclipse started in Oregon, and it traveled across the United States and down out through sort of Georgia, North Carolina, and through the central US. And that was in 2017. And then again, you can see 2024 crosses up from Mexico, Texas, and then up out through the Northeast. So those are the two eclipse paths. In 2024, the path is actually going to be wider. So it's about 115 miles versus the 2017 path of totality, which was about 70 miles wide. In part because of that, and also because of the locations, it's going to be visible by more people. So about 32 million versus 12 million for the last total solar eclipse. The duration of totality is also going to be longer. It's about twice as long in most places for this eclipse, about 4 minutes versus 2. It varies definitely depending on where you are, but that's kind of the average. And the other thing that's really cool about this eclipse compared to 2017 is we are going towards a solar maximum right now. And so the sun goes through 11-year cycles of activity, and we are reaching a maximum. And in 2017, we were actually at a solar minimum. And so this is kind of exciting because they are predicting that the corona is going to be extra large, extra active, and we might see all kinds of flaring and all sorts of interesting activity because the sun is in just beginning its maximum of activity. Let's see, this is a GIF that should be playing, hopefully, where you can see how the shadow is actually going to move. You can see the time counting in the upper right, and that little dark spot in the middle that's going along the yellow line is the path of totality. And then the larger circle, the extended circle, is the penumbra. So that's showing everywhere that people are going to experience a partial solar eclipse. And you can see how it just encompasses pretty much all of North America at some point in its path, in its movement across the United States. And then another way of looking at this is this wonderful graphic, which I think is great. Let's see if this plays. And what this is showing, this graphic is showing the how the partial eclipse will look from each position here on the map as the eclipse moves across the United States. And so you can see in the red lines, that's the path of totality. And so those folks will actually experience totality, but you can look at a variety of different locations. For example, if you want to focus where Nantucket is there, just below the red line in the upper right, you can see how the eclipse will become partial. The sun will look like a crescent, and then it will move out as the moon moves across the surface of the sun. And I should say, of course, it's the apparent surface. It's not anywhere near the sun physically. But that's a pretty fun graphic, and you can find that online if you want to play with that. Oh, it's playing again. We'll just watch it one more time here, just because it's really cool. All right. And then I think I have one more video here because I think the videos just really show us what's happening. This is in 2020, a total solar eclipse that crossed the Earth. So again, there's the dark shadow, and it's moving across the surface of the Earth, so you can see how it moves. This is, of course, a sped up video, so this is not the actual time. And there, the dark thing that's sweeping across, of course, is nighttime. So we have a fixed picture of the Earth, but of course the Earth is spinning, and as it spins, it goes from daytime to nighttime, and then also the eclipse shadow has crossed the surface of the Earth. So I think that's a pretty cool video too, to show what's going on. Okay. All right. So what do we see from Earth? Let's look a little bit more in depth. This is a really nice series of images that was taken. This is the sequential images. So, starting from the left, the moon is starting to cross over the surface of the sun, and then it just keeps advancing. And in this case, they were in totality. So you can see the corona in the middle. And then as the moon starts to move off, you see the crescent again. And there's some fun things in here. The ones right next to totality, they call this the diamond ring effect, where just a little tiny piece of the sun is poking out, and it kind of looks like there's a diamond, like it's a diamond ring, basically. But so what are we going to experience here on Nantucket, in case you want to jot down times that are important? The partial eclipse, so when the disk of the moon first touches the disk of the sun, apparently, and starts to cross over, is going to be at 2:17 p.m. And then maximum eclipse, when it's as fully covered as it can be, and we're going to see the sun as the smallest crescent possible, which is 87% covered. That'll be at 3:30 p.m. So if you're here on Nantucket, that is definitely the time to go out and check it out. And then it'll slowly move across, and it will leave the surface at 4:39 p.m. So that's your timing. here on Nantucket. This is an image that's showing approximately what it's going to look like at maximum partial eclipse, which is about 87%. So it'll be pretty cool. We're going to see this crescent really like a C. And what's really neat about that, and I'll talk about this in a few slides, how to view it, is when you look at this in projection, you will really see these cool C shapes as a in projection. I'll show you some examples of what I mean by that in a second. But here's really quick some other timings, depending on where you're located. You can, of course, look up exactly for your city or town. We have Boston, which is just very similar, of course, to Nantucket because it's not too far away. And New York City. And then folks on the West Coast, San Francisco here, it's going to be a morning event. So it'll start about 10:15 a.m. Pacific time and have about 30% coverage. So they won't see quite as impressive of a display, but it'll still be cool. So should go check it out no matter where you are. So everyone, like we said, in North America will be able to see a partial eclipse, of course, if it's clear out. And so how do you view a partial eclipse? What is the best way to do this? The number one important thing to keep in mind is that you should never look directly at the sun during a partial eclipse. The only time in which it's safe to do so is if you are along the path of totality. During totality, for the few minutes that the total eclipse is happening, you can take off your glasses and look. But that's the only time. And so everywhere else, all the time, including here on Nantucket, it will never be safe to look directly at the sun. So please don't do that. But there's lots of safe ways of viewing the sun. And I've got a couple listed here. So projection, and we'll talk a little bit about what I mean by that, directly with a solar filter, or of course you can live stream the event. So there'll be lots, NASA, the National Science Foundation, the Exploratorium in San Francisco. There's a lot of different organizations that are going to have live streams happening, telescopes viewing the eclipse. So if it happens to be cloudy where you are, I would say just go ahead and get online and have a look for live streaming of the events, because there will be a lot of that and a lot of opportunities to catch it, even if it's cloudy where you are. So what do I mean by pinhole projection? In the upper left here, you can see your kind of traditional cartoon of a pinhole projection. So you have a light source on the left, in this case, the eclipsed sun. So the sun is looking like a crescent. And then you have basically just a card or a board or a piece of paper with a tiny pinhole in it, just a hole. And then what happens is the light projects through there. And it works best if you have a white screen to project it on. Of course, it happens even if you don't have a white screen, but a white screen makes it more clear to see. And you can see what's happening is on the paper, you see the little crescent. And so this is the kind of basic physics of a pinhole camera or a camera obscura. That's the other name for this. And the idea here is that the pinhole creates a projection that is the shape of the light source. So typically the light source is going to be round. The sun is a circle. And so you'd see like a circle. If you just make a pinhole and you go out and let the sun shine through it, you'll see a projected image of the sun as a circle. But of course, when it's eclipsed, it looks like a crescent. And so you can really see these crescent shapes in projection. And that's what you see in the images below. What's really cool, if you don't have a pinhole or you want to try different things during the eclipse, which I recommend, you can even use your fingers. This is what the photo in the middle is doing. This man is holding his fingers up crosshatched, and that makes little pinholes in the holes between your fingers. And look at the projection of the shadow on a white piece of paper. And then one that I think is really cool, if you're lucky enough to find a tree with leaves on it, which it's a little early in Nantucket, unfortunately, for this. There's not a lot of leafy trees yet in this early in the season. But the leaves actually make little pinholes. And so if you go find a tree with leaves and you stand underneath it and look at the shadows and notice, and you'll see between the dark shadow, you'll see projected little crescents when you're in that crescent partial eclipse phase. And it's really, really cool because it kind of messes with your mind. It's not what you expect to see. Another thing you can do that's cheap and easy is to get a colander. So just take one out of your kitchen that has automatic pinholes in it. And here you can see on the right, somebody did this during partiality, a partial phase here. And so you see lots and lots of little crescents, and that's actually the projected image of the sun. So this is a very safe and easy way to observe the eclipse. You can also use more advanced tools to do this. In this case, they've got a setup here with binoculars where they have the light coming in to the binoculars and are projecting it on the white screen you can see over on the right. Of course, you want to be very, very careful and never look directly through the binoculars at the sun because you will go blind. And so and in this case, you have to cover one of the lenses of the binoculars. And so if you do want to look into doing something like this, I would say just be very careful. Maybe read a little bit about it online, how to set it up, and then be really, really careful, especially with kids, because they'll want to look through the binoculars. And of course, that's very dangerous. And then, you can observe it directly with the proper filters. So with the proper eye protection. And here we've got, of course, a pair of eclipse glasses on the left and welder's glasses on the right. You can see folks with number 14 welder's glasses, which is safe for looking at the sun with. Really important to note, of course, you shouldn't look up at the sun and then put your glasses on. You should put your glasses on. You won't see anything. It'll be completely dark. And then look where the sun is, and then you will see the sun through the glasses. So just be very, very careful with looking at the sun directly, because you won't feel it, but you will be doing damage to your eyes. And then, of course, you can do look with telescopes that are outfitted with the proper solar filters. We have one here at Maria Mitchell. And so if you are on Nantucket, we will be using this during the eclipse. And so we're open to the public and inviting everyone to come on down and take a look through our solar telescope at the sun. So that's for the partial eclipses. Now, if you're lucky enough to be on the path of totality, you will see a total solar eclipse. So this is again for this eclipse, it's anywhere along this yellow path. And I have to say, I saw one there's some audio here of people experiencing a total solar eclipse. I'm just gonna... Oh, it's a little bit loud. I'm not going to play that. Anyway, I have to say, I saw the 2017 one, and pictures and video do not do it justice. It's like nothing else. It becomes nighttime in the middle of the day. The stars come out. You can see the stars. You can see the planets. It's basically like twilight all around the horizon, almost like sunset, but it's 360 degrees around. Animals and birds freak out right before, and then they become really quiet during, because of course it all of a sudden became nighttime in the middle of the day. It's just absolutely indescribable. I can't really describe it, and I feel like pictures and video don't do it justice. So, if you can get to totality, I highly recommend it. And this is the advice of professionals. If you are in totality and you want to take photos and videos, don't, because totality is short and it will be over quickly. And being there and actually experiencing it is, extremely rare and valuable. And if you're messing around with your camera and your video, you'll be missing the moment. And it turns out it's not captured well on, I think, cameras and videos. So, this is some very cool images of an April 20th, 2023 total solar eclipse from Australia here. And they are showing, sort of what we expect we might see in this April 8th eclipse, again, because we're close to a solar maximum. And so this is sort of showing, that it's potentially going to be very, very cool with the sun being so active right now. Okay, so we have a little bit more time, so I'm going to go into a couple more in-depth topics here dealing with the eclipses. So I'm going to just talk briefly on the different types of eclipses there are, why they don't happen every month, the fun cosmic coincidence that we live in, which gives us eclipses at all, a little bit of myths and lore of eclipses, and then I'm going to end with some science, what science do astronomers actually do. So here's a little cartoon diagram of the different types of eclipses. At the top, you can see the alignment when you have a total solar eclipse. So this is what's coming up. Every once in a while, you'll have what's called an annular solar eclipse. And that's when the moon is slightly farther away from the Earth in its orbit than it typically is. And therefore, it doesn't quite completely cover the disk of the sun. So you end up with a ring of sunlight around it. We had one of these back in October of last year. And so during an annular solar eclipse, it is never safe to look at the sun directly, and you also don't see the solar corona because that ring of sun, direct sun, is so bright compared to the extended corona. And then at the bottom is a partial solar eclipse, of course, when the Earth is just in the penumbral part of the shadow, so not the deepest, darkest part. So why don't we have them every month? The reason for that is because the moon's orbit is tilted with respect to the plane of the solar system. And so at about 5 degrees, which you can see here. And so the alignment has to be correct in order for those shadows to really fall on the other body. And most of the time it does not happen. That's why we don't have eclipses once a month. And you can see that in this little bit more complicated diagram. But you can see sort of in the middle how the square is tilted up with respect to the larger plane of the solar system there, which has the sun at the center. And the circle around is the Earth's orbit around it. Again, this diagram is not to scale at all. And so please keep that in mind. This is very cool, though. It's kind of a coincidence. It is a coincidence, in fact, that we have total solar eclipses. And in case you didn't know this, the reason we do is because the sun, the apparent size of the sun on the sky, is the same size as the apparent size of the moon on the sky. And the fact that that is true is a coincidence, but it's a result of the fact that the sun's diameter in reality is about 400 times the moon's diameter, but it's also located about 400 times farther away than the moon is. And so because you have these ratios that work out, they work out essentially so that we actually can have total solar eclipses, which is pretty cool. There's no deeper meaning behind this. It is a coincidence, but it is a pretty cool one. Earth is not the only planet to have eclipses, by the way. This is a pretty cool video. Let me see if it'll play here. So this is the NASA's Perseverance rover watching a solar eclipse on Mars. So here's the sun as seen from the rover sitting on Mars. And what you're seeing here is one of Mars's 2 moons. This is Phobos. Mars has two moons named Deimos and Phobos. And this is the Phobos crossing in front of the sun. Of course, you can see that Phobos is not round. It's kind of got an interesting shape to it. And this is also sped up in time. So this is a sped up video here. But I think it's pretty cool. And of course, Mars will never experience a total solar eclipse, as you can determine from that video. Okay, just a real quick touch. Of course, human beings have experienced eclipses since the beginning of human beings. And so, you know, there's a lot of history and lore about eclipses and what they mean. And here's a quote by the director of the Griffith Observatory. "If you do a worldwide survey of eclipse lore, the theme that constantly appears, with few exceptions, is it's always a disruption of the established order." And you can see here some images. The one on the right shows an ancient Chinese myth of Tiangu, who was a black dog who ate the sun. We have modern day, of course, lore about eclipses. Some of you may have seen this movie. And in every culture around the world, of course, there are stories that explain eclipses, why we have eclipses and whatnot. I liked this quote by Jorita Holbrook, who's a cultural astronomer at the University of the Western Cape in South Africa. And she said, "My favorite myth is from the Bantu-Balia people in Togo and Benin in Africa. In this myth, the sun and the moon are fighting during an eclipse, and the people encourage them to stop. They see it as a time of coming together and resolving old feuds and anger. It's a myth that's held to this day." And I did a little research once to figure out when, um, who were the first people to actually understand what was happening during eclipse. You know, people of course experienced them, and tried to explain them with all sorts of different stories and whatnot, as we just heard. But who actually understood them first, and kind of scientifically what was going on? And this is what I could find, who was this Greek fellow, Anaxagoras. And he actually, he said several revolutionary things, including that the sun and the stars were fiery rocks very, very far away. And that's why we don't feel their heat, because they're located very, very far away. Of course, well, maybe not the rock part, but the fiery part and far away, you know, he was actually correct. Turns out people didn't appreciate it back then either. And I think he was actually, um, killed for this. However, he was the first one to, as far as I can tell, correctly explain what's going on during an eclipse. And we know that the Greeks probably then, you know, did eventually come around and explain it. And not only explain, but they actually probably could predict them. If you haven't heard of this, the Antikythera mechanism, this is really cool. This is a picture of it on the right. It was discovered in 1901 in an ancient shipwreck off Antikythera. It's dated to about 87 to 205 BC. And it's taken a while to figure out what exactly it does. It's clear it's some kind of mechanism or machine. Here is actually a computer reconstruction of what we think it looked like. And there were about 30 meshing bronze gears that probably predicted the timing, the dates and timing of eclipses. So there's a paper about this, eclipse prediction on the ancient Greek astronomical calculating machine known as the Antikythera mechanism, which is pretty cool. So people have actually known about and understood eclipses for centuries. And, you know, why is that? Well, it turns out eclipses do have periods in which they happen. And this is because it's an alignment issue. So, right, it's the sun, the earth, and the moon, and they have to be in the right alignment. And of course, that happens on a repeated pattern. Now, it's a little bit complicated, the repeated pattern, but there is a pattern. And it's called the Saros cycle. So eclipses occur in cycles because the orbits of the earth and the moon follow a pattern with respect to the sun that aligns every 18 years and 11 1/3 days. This is an interval known as a Saros. And it's a little bit different depending on the leap years. So we have leap years and leap days added in. But you can see here, for example, this map is showing this particular Saros cycle that corresponded with the 2017 solar eclipse, and how that particular alignment of the Earth, Sun, Moon sort of repeated or will repeat in these 18-year, 11-day cycles, basically. A little bit more on science related to eclipses. I think this is really cool, having to do with Einstein and general relativity. Just to refresh everyone's memories, in 1915, Albert Einstein published his general theory of relativity. And this theory basically says that, he was trying to explain gravity, essentially. And, historically, people thought of gravity, like Newton, as a force that the Earth pulls down on things, and that's what gravity is. But Einstein thought about it a little bit differently, and essentially says that there is no gravity, but what's actually happening is that mass, so the Earth, is distorting the space-time around it. And that distortion of space-time is what we think of as gravity, we feel as gravity. But the distortion of space-time also affects light. And so we don't really have a sense for this necessarily in our day-to-day experience, but when you start to look out in the space and in astronomy, you do see effects of this. So mass distorting the space-time around it, and you see what we call gravitational lensing. And so that means that, a foreground massive object will bend the light that is passing by it. And so Einstein actually predicted this, and I have an image just in a second that shows what I'm talking about. But Einstein predicted this in 1915. And he realized that a really good test, a physical test for his prediction, which is based on general relativity, would be could happen during a total solar eclipse. And the next total solar eclipse that was happening was on May 29th in 1919. And he got together with his friend, Eddington, a famous astronomer at that time. And Eddington put together an eclipse expedition to the island of Principe off the west coast of Africa to observe this total solar eclipse and to try to see if they could confirm Einstein's theory of relativity. And so what you see here is the physical setup of the test. So of course you have the sun, and you can see the grid in the background is supposed to represent how the sun's gravity, so the sun is very, very massive, and how that mass is distorting the space-time. And then you have the Earth, and these sort of rays of light are actually, let me put up my next slide here, a light coming from a distant star on the other side of the sun. And so what happens is the mass from the sun distorting space-time will make a star that's located far, far away appear sooner than it actually should because of the distortion of space-time. So in other words, Eddington knew that if general relativity was correct, they would, during the eclipse, they would be able to see stars in the background. And they knew the exact location of those stars, and they knew when they should appear and where they should be in the sky. But because of the distortion from the foreground gravitational mass of the sun, the stars actually appeared before they should appear. And that's kind of this diagram you see right here. So the star was actually still behind the sun, but the light was being bent in such a way that we could see before if there was no general relativity, before it would actually be visible. Hopefully that made sense. So we now, of course, today know that Einstein's general relativity is correct, and we see it all the time. This is a famous gravitational lens here. What you're seeing on the left is a quasar, so a really, really bright, supermassive active black hole. And it's being lensed 4 times, actually. So the thing in the center is a foreground sort of massive galaxy, and behind it is this distant bright light source, and it's being lensed 4 different times. That's what that little cross-looking thing of lights. Here's another example of that. This is a more modern example. You can see the orange blob in the middle is a foreground massive elliptical galaxy with a lot of mass. And in the background, there's a blue galaxy forming stars, but it's actually the light is being lensed into this great big arc. So that arc is not what the galaxy looks like. The galaxy looks probably just like a little sort of spiral or something like that, but the light is being all stretched out because of this gravitational lensing, which Einstein predicted. If you are interested in this, there's a fantastic movie on the BBC. It's now several years old, called Einstein and Eddington, that tells the story of Einstein and Eddington's collaboration and trip to view the solar eclipse in 1919. Okay, the last topic, and then we'll wrap up, is about the science. So what are astronomers doing scientifically during eclipses? And I think the main focus, I mean, there's lots of things, but one of the main things is studying the corona, which is this hot, extended outer atmosphere of the sun. The corona is millions of degrees hot. It's actually extremely hot. Whereas the surface of the sun is just about 5,800 degrees hot. And we don't understand how that happens. We don't quite yet understand how the corona can get so hot when the surface of the sun is really only about 6,000 degrees or so. And it's not by radiation and it's not by convection. And so that's not really well understood yet. And so a lot of astronomers are trying to understand that. This is an image of the corona taken from a spacecraft that's orbiting. And what you can see is the spacecraft has something on it called a coronagraph, which basically creates like an artificial eclipse because the spacecraft detectors would be overwhelmed from the light of the sun. So it has this coronagraph disk basically that it has in place over the image of the sun. And here, what you can see is they've placed, just for us viewing, a picture of the moon there. So you can see that's where the actual surface of the sun is. But they've had to make the coronagraph a bit bigger because everything is so bright, basically. And so what we really want to study is, of course, this outer corona, but then that region right up to the surface of the sun is really important to study. And it's really only accessible during a total solar eclipse. And so there's a lot of astronomers who focus on this, and so eclipses are really big for them. One of them is shown here, Shadia Habal, who's at the University of Hawaii. And during almost all eclipses, she goes with a team and sets up a variety of different telescopes all along the path at different sites, and tries to get data on the solar corona. This coming eclipse in April, there's actually going to be another project called ACES, sponsored by the National Science Foundation, the Airborne Coronal Emissions Surveyor. And you can see in the picture here the PI, Jenna Samra, who's here at the Center for Astrophysics at Harvard. And their goal is to observe the corona in infrared emission. And so they're actually going to fly up on an airplane really high, I think 40,000 feet or so higher than your standard commercial flight, so that they can access this infrared radiation, which doesn't typically come through our atmosphere so well. And so they're going to try to observe the infrared radiation, and they're going to fly along the path of totality, of course, to try to maximize their observation time. And here is an image of a total solar eclipse from 2008. And in this image, they've colored different ions of the element iron in different colors here, so that you can see this is basically how you get science out of this. And so studying where these different ionization states are allows you to determine the temperature and sort of the flux of energy. And this is one of the big open questions. Okay, so I'm just about done here. And so, eclipses are really super cool, just, in all ways possible. So I hope that you get out, and no matter where you are, try to observe on April 8th. I hope you have clear skies. And, you should do it because the next total solar eclipse visible from North America will be in 2044. So 20 years from now. And I was curious about the path. So I looked it up, and actually you can see here, this is the path. So it's really only barely visible from most of the United States. You've got to be right there, sort of in North Dakota and Wyoming, in order to see totality for that eclipse. So it's not that even in 2044, it's not going to be one of these great ones that crosses, a lot of the United States. So please do try to check it out on April 8th. And I hope you have clear skies. If you are here on Nantucket, we have several events that we're hosting this Saturday, April 6th. We're going to have a short talk about the eclipse, and then a workshop to make pinhole cameras, which is a nice, safe way of observing the eclipse. So the presentation will be 2 to 2:30 p.m. At the Mariah Mitchell Research Center on Vestal Street. And then we'll have the pinhole camera making workshop after that from 2:30 to 4 at Hinchman House. And you can find details on our website. This is free and open to everyone, so please swing by. And then on Eclipse Day, on April 8th, we will be hosting an event from 2:30 to 4:30 on the Nantucket High School retired baseball field. And we'll have, like I said, our solar telescope. We'll have our sunspotter viewer. We're going to have solar eclipse glasses. Everyone is welcome. So please come on down and join us for that if you are here on Nantucket. And I will stop there and see if there are questions. And thank you all for your attention.
That was great, Regina. Thank you so much for preparing this presentation and sharing with us all of the wonders of the eclipse and the upcoming eclipse. We do have a couple of questions and I'd love to get them kicked off for you. Our favorite astronomer and children's book author, Sharon and Dan, are asking, what are your telescopes doing during the eclipse, or our telescopes rather?
Yeah, great question. So we won't be using our normal nighttime telescopes, the 24-inch and the Clark refractor, because they're not outfitted with solar filters. And so we actually won't be using those, but we do have a solar telescope that's specifically designed, for this, and it's safe. And it's really cool. So we'll have the solar telescope there at the baseball field. And so please come by and check it out, check out the view through the solar telescope.
I think Dan and Sharon might be lucky enough to be in the path of totality as well. He also asks, why does the path of the eclipse move west to east, but the Earth is rotating to the east?
Yes, right. Well, because of that, basically, because the Earth is rotating to the east, and the sun is, you can think of the sun as still, and so the Earth is rotating underneath the shadow. So the shadow, you can think of the shadow as fixed, and so as the Earth rotates underneath it, the Earth is rotating to the east, and so it appears that the shadow moves west to east. So it's basically, yeah, for that reason. Hopefully that made sense.
It did. Can you tell us a little bit more about what to expect here on Nantucket on Monday for the activities that we're preparing for the general public?
Yeah, definitely. So we will have the solar telescope, we'll have the sun spotter. So we have a kind of it's a projection viewer basically that magnifies the image and creates a projected image, which means multiple people can look at it at the same time. So we'll have that. We will also have the solar eclipse glasses, so you can look at it directly with the safe solar viewing glasses. And then we're also going to have some pinhole making materials. So if you don't have a pinhole camera yet, you can come on down and we'll have a station where you can make your own pinhole. A really fun thing to do, and you might see pictures of this if you go online and Google it, is to make art with pinholes. So you could, for example, make pinholes of, say, your name, or I saw actually a really cool one from 2017. Somebody did the outline of Nantucket in pinholes, and then you can, you see basically the projected image of the eclipsed sun. So all these little crescents in the shape of Nantucket Island, for example. Or you could do your favorite, state or shape or image, something like that. So we'll have supplies to do that as well. So especially if kids want to do some art, we'll have that available for folks.
And fingers crossed for clear skies and good weather.
Yes,
Definitely.
fingers crossed for clear skies. It looks right now like it's supposed to be pretty good here. So yeah.
Keeping the fingers crossed and my
Yeah.
toes. Can you tell us a little bit more about the relationship between annular eclipses and total eclipses, and as well as the relationship between lunar eclipses and solar eclipses?
Yeah, sure. Well, so the total ones are the really cool ones, right? Because that's where you get totality, and experiencing that is like nothing else. They're essentially all the same though, in terms of solar eclipses. So it's always the same alignment where and I guess the difference is just like, is the moon slightly closer or slightly farther away? The moon's orbit around the Earth is not a perfect circle, it's slightly elliptical. And so it depends where exactly it is in its orbit when that a special alignment happens. And so this is again, something that changes kind of as everything is orbiting around each other, and the Earth is orbiting around the sun, again, not in a perfect circle but in an ellipse. And so this is basically again why we don't have eclipses, or related to why we don't have eclipses every month.
Mm-hmm.
A lunar eclipse is different though, because it's kind of the let me see if I can go back to that slide. It's the sorry for going through the slides so quickly.
I guess while you
I'll go to the cartoon right here. Yeah.
Yep. Go for it.
So with a solar eclipse, you always have, you know, the moon in between the Earth and the sun.
Mhm.
With a lunar eclipse, you'll have the Earth in between the sun and the moon.
Mhm. I guess a follow-up question to that, or to break my question out, is it always guaranteed that when you have a total eclipse that a lunar eclipse precedes it? Do
No,
they come in tandem, or is it kind of just coincidental?
yeah, it's not guaranteed at all.
Mhm.
Yeah. So the fact that, right, I know what you're thinking of. We had a lunar eclipse
Yep.
last week.
Yep.
Yeah. No, not necessarily. That doesn't always happen. I think that, you know, sometimes happen. I don't know off the top of my head, like what percentage of the time that
Mhm.
they occur so close together. I mean, um, because again, it's this funny tilt, right?
Right.
And so it is predictable, but it's not regular. So
Yep.
like I can't, you know, it's kind of like when people ask me what planets are up in the sky. Like we know, but it's not like every June we're gonna have Saturn up,
Right. You're gonna
because
see
it
the same
depends.
exact things.
Yeah, exactly. Because it depends
Mhm.
where every planet is in its orbit around the sun, and those have specific periods, but they're not necessarily regular with respect to each other.
Awesome. No, thank you. Super helpful. And of course, guys, if you have any other additional questions, please pop them in the Q&A or in the chat box. You can raise your hand. I can give you mic privileges, whatever you would prefer. And while I wait, I'll ask another question. How exactly did we determine the Saros cycle? Was it from direct observation? Was it a mathematical calculation? Not sure if you know, but that was just something that popped up.
That's a really good question. Um, I mean, I suppose, you know, I don't know for sure, but I suppose that's pretty much what the ancient Greeks figured out.
Hmm.
And um and what the Antikythera machine mechanism um uses, or something close to that. Um and so I think it's probably been known for a while, at least approximately. You know, I don't know how precise the Antikythera machine mechanism
Hmm.
is at predicting eclipses, but it seems like, from what I know, from what I read, it did a pretty good job. And so um, in order to do that, you need to understand these cycles, basically.
Hmm.
You know, how long it takes for the moon to make one orbit, but at the same time, the Earth is orbiting around the sun. And so you have essentially these different kind of cycles that are all important, and figuring out how those different cycles interact with each other and then create the right alignment to create an eclipse. So it's not necessarily hard, but it's not easy to sum up in, you know, like, oh, eclipses happen every 8 years, exactly this spot will be eclipsed. That's why it kind of changes a little bit. And the Saros cycle,
Right.
while the eclipse pattern looks similar, it's in a slightly different location on the Earth, for example, that
Mhm.
path of totality. So it's simple but complicated. It's a
Yeah.
funny, yeah.
Definitely, I would agree. So this is not a question, just a big thank you to Regina and Janelle. We will be here on Nantucket for the eclipse. Trip to Texas did not work out, Sharon and Dan. But I'm sad to hear that, Dan, but also exciting that, again, our favorite astronomer will be here for our partial eclipse.
Yeah, and I have to say, when I last checked, Texas weather wasn't looking that great, and I'm going to Texas for it, so I'm a little bit nervous about that. But so you might have better conditions here on Nantucket, actually.
And Dan and Sharon, of course, if you guys, want to come down, if you want to do anything collaborative with us, you know how to find me. I had someone raise their hand. Let's see. Diane, you raised your hand, and I've given you speaking privileges if you'd like to give that a try.
Sorry, that was a mistake.
Oh, no worries. Well, it's nice to hear your voice regardless.
But thank you very much for your great presentation. This was really interesting with so many different facets of it, and I'm enjoying all of these great presentations that everybody's doing. But this is particularly great, very easy to understand. So thank you, Regina.
Awesome. You're welcome. Thanks for your comment.
Thank you, Diane. Right. And I think for me, I have so many questions and I love being able to see you in office and ask them. I think what I'd like to wrap with is just if you can remind everyone, the safe viewing tips for
Oh yeah,
wherever they are. I
yeah.
think that's a great way to close this out before I just give thank you to our sponsors.
Sure.
Unless there's anything else you wanted to share with us, because I know that there's so much to talk about always.
No, I think the safe viewing tips is a really good way to end because it's very tempting to, especially if it's partly cloudy, to like try and look at the sun. We did this, during the October eclipse, and you kind of, it doesn't hurt your eyes because it's partly cloudy. You don't feel like it hurts.
Mhm.
But I would advise people not to do that because it is hurting your eyes, even if you can't feel it.
Right.
And so really important to wear the glasses. I was in a workshop where I learned the proper way to teach, especially kids, to use the
Mhm.
glasses. And we've talked about this. So basically, look at the ground, put your glasses on, and then look at the sun, and then look back down at the ground or at your shoes and take your glasses off.
Mhm.
Because it's tempting. Once you put the glasses on, you can't see anything because they're
Right.
dark. And so people get confused and they kind of want to take them off to find the sun. And that's exactly not what you should do. So, especially with kids, tell them to look at their shoes, put their glasses on, and then look up and find the sun. And you will see it. You won't see anything else, but you will see the sun through your glasses. And then look down and take your glasses off. So that's kind of the best practices. And especially with kids, it's good to try to make sure they don't look at the sun and damage their eyes, and you won't necessarily feel it at the time. You won't
Right.
know. But it is not it's not great for your eyes. It's not recommended. So be very
Definitely.
careful with that. And the projections are great. So if you don't have glasses, try to get your colander out or make a pinhole camera. And those are really great ways to view it as well.
Yeah. And we do, for anyone on Nantucket, we still have some glasses for sale if anyone's interested. And definitely during the workshop on Saturday, we will be handing those out as part of the workshop as well as on Monday while supplies last, of course. And what I thought was, really awesome and worth mentioning is that we've been so lucky to, collaborate with the public schools here. And Regina has and her team has created this excellent resource that we've been able to share with the community of how to safely view the eclipse this upcoming Monday. So I'm happy that everyone is equipped to be safe. And we again hope for clear skies and success. Well, Regina, thank you so much for this wonderful presentation. To just echo Diane's sentiments that it was just so easy to follow and so informational and educational at the same time, as well as with the historic piece. Mariah Mitchell, she, pioneered a lot of this for us today. And I just also wanted to thank Bank of America, our lead sponsor of our Science Speaker Series, as well as Cisco Brewers and the White Elephant Hotels and Resorts of Nantucket and Palm Beach of making, or rather for making, this Science Speaker Series presentation and all of the ones before and the ones that are upcoming accessible and free to all of the public. So I thank you all for joining us this evening. And again, it's been my distinguished pleasure, Regina, to host you this evening.
Thank you. Thanks so much, Chanel. And thank you, everyone.
Thanks, everyone. Have a great night.
Bye.